Hello everyone, I hope you all are doing well. So today we'll be starting with the chapter complex numbers. Now when we talk about complex numbers, what comes to our mind first? The numbers which are imaginary. Now these numbers include the numbers which are real as well as imaginary. Now till now we were studying completely about real numbers, we were studying about quadratic equations, how we could find our real and distinct roots. However, whenever we used to have imaginary roots, we weren't able to find it out, right? Now using complex numbers theorem, we would be able to find out our imaginary numbers as well. So basically complex numbers are like the universal of all types of numbers. Real numbers and imaginary numbers are basically a subset of complex numbers. So that is what we are going to be studying in this chapter. Again, this chapter is not very important, but still there have been a lot of questions that have been asked in JEE Mains previously from this chapter. Mostly what JEE does is it uses the concepts of this chapter in other chapters and then asks questions. So again, it is better if you understand this chapter properly and learn it. So talking about the subtopics that we are going to be covering in this chapter, firstly we'll look at a brief introduction as to what complex numbers are, what are they. Then we will be looking into the powers of iota. I hope you all know what iota is. These are just a few basic topics that you've already studied in your school time. Then we'll be looking at the algebra, graphical representation, its argument, and then we will be looking at different forms of complex number, this and cube roots of unity. These two are the most important parts of this chapter. Then locus, rotation, and nth root of unity are also a few topics that we'll be looking into. So let's start with the introduction. First of all, as I mentioned, complex number is basically the universal of all types of numbers. So let's say if I was to represent, let's say if this circle here, this represents my complex numbers, then real numbers are basically a subset of this complex numbers. And in real numbers, of course, we have two types of real numbers. One is rational real numbers and one is irrational real numbers. So here we are going to have rational, here we have irrational. Now, what is the subset of rational numbers? We know it is integers, and integers subset is going to be whole numbers, and then again its subset is going to be natural number. So natural number is generally considered to be the smallest set of numbers. This is my natural numbers. Let me write it down clearly for you. This is my whole numbers and this is my integers. So here in complex numbers, we've already studied a lot about real numbers till now. Now we will be looking at this another subset as well, which is our imaginary numbers. So now we will be looking basically at the combination of this real and imaginary numbers and how we can solve those questions using our graphs or maybe using our formulas and all those things. So first of all, when do we need complex numbers? Let's say if I have to find out x square plus 1 is equals to 0. Of course, till now I used to say that this is not possible, right? Because there is no value of x that can make x square as minus 1, and so that we can get this equation to be 0, right? So now comes the concept of complex numbers. I can write x square as minus 1, so x can be written as root under minus 1. If x is root under minus 1, I used to say that this is not possible, right? This is going to be some imaginary number or some undefined number. Now what I say is this root under minus 1, I define it as a variable known as I, which is also called as the iota. Now I'm going to solve all of my questions and all of my complex numbers, or let's say my imaginary numbers, based on this variable, which is iota. So remember this thing, root under minus 1 is what we call as iota. So basically if root under minus 1 is my iota, that means what is the values of x that I'm going to get after square rooting minus 1? It is going to be plus minus iota, because whenever we square root anything, we get usually two values, right? One is the positive value and another is the negative value. So similarly here I'm going to get plus minus iota. So this is basically what my complex number is. Now let's say you must be thinking, how do we generally represent any type of complex number along with a real number? Generally my complex number is represented with a variable z, where we write this as x plus iota y. This is the general representation of a complex number. So general form of complex number. Here you can see that x, this is considered to be my real part. Here y is considered to be my imaginary part. And iota here, iota is nothing but root under minus 1, or we also call this as the imaginary number. So basically this is a type of a format in which we represent our complex number, so that we can show our real part separately and our imaginary part separately. This iota basically is there to distinguish between these two portions. Now again, the same things have been mentioned here. A complex number is a number that can be expressed in the form z is equal to a plus b iota, where a and b are real numbers and iota is an imaginary unit. So here what happens is x and y are of course real numbers. Now this iota y, entire thing, this would transform this into the imaginary part, where iota square is equals to minus 1. Here a is called the real part and b is called the imaginary part of the complex number. So I hope you must have understood up till here. Now let's say if I have z is equals to a plus iota into b. Now if I want to represent only the real part of this z, how do I write it down? I can write it as this format also, real part of z. So this would become a. And how do I write down the imaginary part of z? I write it as imz, so it would be b. So keep this in mind, the imaginary part is not iota b, it is simply just b. Iota is there for us to differentiate between the real part and the imaginary part. So keep that thing in mind. Now here there is an important note that has been mentioned. The property root x into root y is equals to root xy. This is not valid when x and y both are negative numbers. Now let me take an example. Let's say if I have root 4 into root 2. What do I usually do? I simply write it as root 8, right? Now let's say if I have root of minus 4 into root of 2, I can write it as root of minus 8. Now how can this root of minus 8 be represented as? This can be represented as root of minus 1 into root of 8. Thus it becomes iota into root 8. Now I can write this negative value inside the root under in this format. Now what if I have root under minus 4 into root under minus 2? I cannot directly multiply these two numbers, because if I directly multiply these two numbers it would become root 8, right? However, it is not the case, because root under minus 4 is not possible, root under minus 2 is also not possible, right? But if I multiply these two together, I am getting root 8, which becomes a possible value. So that cannot be the case. So generally what happens is we use imaginary numbers to represent this. So this generally is written as iota into root 4, and this is also written as iota into root 2, and thus this becomes iota square into root 8. Now this is the way how I can represent this. And what is my iota square? Simply it is minus 1, so it becomes minus root 8. So keep this thing in mind. Whenever we have root under minus 4 into root under minus 2, it becomes minus of root under 8. This is an important concept that you must remember about root 4 into root 2, root minus 4 into root 2, and root of minus 4 into root of minus 2. So keep this thing in mind. Now this value of complex number that we just studied, which was z is equals to x plus iota y. Now this can be represented in two different forms. Basically one which we call as the purely real number. Purely real number means that there is no imaginary part here. Purely real number means no imaginary part. This means that my y would be equal to 0 basically. So my z would simply be equal to x. Now other type of this complex number is purely imaginary number. Now what is a purely imaginary number? Where I would have no real part in it. So there would be no real part in this number. So basically what I'm saying is my x is equals to 0. If my x is equals to 0, that means my z becomes iota y. So I have only the imaginary part in this portion. So again, sometimes what happens is that in questions they usually give you that they are going to say that let us assume x is an complex number. That means you can say x is equals to a plus iota b. And then they would say that x is actually a purely imaginary number. From there, it must click to you that it is a purely imaginary number, which means that a value in that number is going to be 0. That means there's going to be no real part, only the imaginary part, which is iota b. So keep this thing in mind as well.